Alright friends, today we're going to talk about section 8.1, graphing. I'm going to start off with the rectangular coordinate system. Now what the rectangular coordinate system is we have a horizontal axis called the x-axis and we have a vertical axis called the y-axis. As we move to the right on the x, it increases 1, 2, 3, 4 and it keeps going forever. And as we move to the left on the x-axis, it keeps decreasing, -1, -2, -3, -4, so on. With the y, again, that's the vertical axis. As we move upward, it increases, and as we move downward, it decreases, and the place where they intersect is known as the origin. And that's at 0 and 0. 0 on the x and 0 on the y. Okay? So, an ordered pair always looks like this. We have the x component first, and then the y component first. Always. They use soft brackets, and they're separated by a comma. So, for example, the ordered pair 3 and -4 means we start at the origin, we go out 3 on the x, and then down 4 on the y. Always do the x first, then do the y. Okay, and then you can put your point right there. This is point -3 and 3 and -4. For example, though, if you wanted to try a few, plot some points here. We have 4 and 2, our first one. So we're going to go out 4, we're going to go up 2. There's our first point. Our next point, 3 and -3, we're going to go out 3 and down 3, right there. And then -1 and 0, we're going to go back 1, and we're going to go up none, and there's our last point right there. Okay. So also for an example, you can write the coordinate points of these points here. So again, if I look down, I can see that this is at point -4, and if I look over, this is at point 3. This guy here, B, this is at 2 and 2, and C is at 1. C's right here, 1 and -3, 1 and -3. Okay, there you go. One quick thing I want to touch on, graphing utilities. This comes from the TI-83, which you don't need or really require at all, but sometimes they will give you a question. I think there's one that randomly pops up, and it'll talk about the viewing rectangle. Okay, so it looks like this. The first little bracket here, the first set is the x-axis. The second one refers to the y. Okay, and the first number here means the minimum x value is -100. So if we're looking at a graph, the last tick to the right, let me try to show you a picture here. No picture. The last tick to the right, if we had a bunch of ticks here, like tick, 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 so on and so forth, the most negative one would be -100. The second number, the maximum, would be the maximum number, so that would be 100. And then the last number here means this is the distance between each tick mark on the graph. So the minimum is -100, the maximum is 100, and we're going up by 50 each time. So this would be -100, and this would be -50, so on and so forth. This is not to scale, I just went crazy. Same with the y's. Okay, we have tick marks on the y-axis. The minimum value would be -100, the maximum value would be 100, and then it would go up each time by 10. That's just what that means. So I just want to make you aware of that. It pops up in a question or two. Next, let's talk about a linear equation where we have two variables, x's and y's. Generally, they're written in this form, ax plus by equals c. And a solution to a linear equation is an ordered pair that makes a true statement. So let's check this one out. If we have 2 and 1, is that a solution to this equation, 2x plus y equals 5? Well, remember, with an ordered pair, we have an x and a y component. So I'm just going to write down my equation, 2x plus y equals 5, and then I'm going to sub in those values. X is 2, so I'm going to sub that in for x. Y is 1, so I'm going to sub that in for y. And now we're going to do order of operations. 2 times 2 is 4, plus 1 is 5. So I get a true statement. This is true. 5 equals 5. So therefore, this ordered pair is a solution to this equation. Next, let's look at functions. And a function is a very specific relationship. And basically, any graph, any picture, is a relation. It's showing the relationship between two variables, in this case, x and y. Okay? But it's a little bit more specific for a function. So all functions are relations, but not all relations are functions. Here's what I mean. A function is a specific type of relation where for every x value, we have one and only one value of y. So you can see if x was -3, I get a value on y of 4. There's no duplication here. If x was 1, I get some value. If x is 2, I get some value. There's no overlapping here. Okay? This is a function. So we don't have to graph ordered pairs. I mean, we could plot each one of these and connect them with a straight line if we wanted to. But basically, figuring out if this is a function, we're looking for duplication in the x coordinates. So here's all the x coordinates. And if we have all different numbers here, this is a function. So I have 3, 10, 11, 13, and 9. Those are all different numbers. There's no overlap there, so this is a function. Another new term is called the domain. Now the domain consists of all the x values for a function. So here, literally the domain of this, I would just list this. I would say it's 3, 10, 11, 13, 9. You can just list them. You can list them in order if you want, but it doesn't really matter. The range consists of all the y components. So we have 5, 12, 8, 15, and 12 again. We just list them. Notice I'm only going to list 12 once though. Okay? I'm not going to get carried away there. We can have duplication of the y coordinates, that's okay, but we can't have duplication of the x's. If we do, it's not a function. Okay? So, a couple of questions here. You might have to state the domain and range of a set of ordered pairs. Well, again, the domain is just those x coordinates, 2, 5, -3, 2, and 1. So you just list all those. Don't list them twice. The range is all the y's, 4, 8, 6, and -7, so you can just list them like so. Notice how we have a 2 in the x, and we have another 2 in the x. So therefore, this is not a function because we have that duplication. Graphing. Next thing, we're going to look at graphing by making a table of values. So what you do is you take a table. We're going to pick x's and y's. You pick the x's, and in MyMathLab, it makes it even simpler because MyMathLab will pick the x's for you. And what you do is you sub it into your equation. So this equation here, y equals x squared, means we're going to take the x, whatever it is, and we're going to square it. So if x was -2, -2 squared is 4. That's going to be our answer for y. And really what we've done is we've just made an ordered pair, -2 and 4, which we could plot right here. We do the same with every other value of x, sub it in. So -1 squared would be 1, 0 squared would be 0, and so on. And we plot all our points, and then you can connect them with a smooth curve. That's how you can graph by constructing a table of values. Here's another example. The formula is slightly different now. Now it's x squared plus 3, but it's the same play. MyMathLab will pick these values of x, and you just sub them in for x and solve it, okay? So -2 squared plus 3, well, that's going to equal 4. 4 plus 3 is 7, and you just kind of go through like that. Here's another one, same play. Now, let's take a look at the vertical line test, and this is going to tell us if a picture of a graph is a function or not. So for every picture here, A, B, and C, if we imagine a vertical line test, a vertical line, which is black here, and it's kind of passing through each, as it moves through, you got to use your imagination. It's kind of going down, 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 through, and through, and through. If it touches a graph at only one point, it's a function. So here you can use your imagination. This line is only going to touch the curve at one spot. That's a function. B, we can see very clearly that it's going to touch the line here and here. Therefore, it is not a function. And same with C, not a function. So the vertical line test, just use your imagination, pass a vertical line right through it. You could also use a ruler or whatever just to visualize it. If it only touches once, not a function. Okay, so that's it. Hope that helps. Let me know if it doesn't.